Okay, energy levels. What do we got for an energy level? Anybody? Energy level? You want to say? Okay, let's start off with there are 7 of them. Is this analogous to anything you know? Maybe a Disney movie? Or a periodic table?
Wait, how does seven rows? Or the 7 horcruxes. Come on. Oh, okay, I'm back. Sorry.
Anyway, 7 rows on the periodic table corresponding to the 7 energy levels, but we still don't have an energy level definition. What? How about location? It's a general location of the electron. So the energy level has what inside of it? So there holds the sublevels. All right, so 7 of them, it's where the electrons are located. It's a general location, and it's the thing that holds the sublevels. So what about the sublevels? The sublevels hold orbitals. We should probably go along with there were 7 energy levels. What about the sublevels? Also 7. What are they? H and I. Okay. And each energy level has its number of sublevels. So what do we mean by that? Energy level 3 has how many sublevels? 3. Orbitals. Holds up to 2 electrons. It could have none in it, or it could have 1, or it could have 2, but you can't have any more than 2. Electron configuration for nitrogen. What do we got? Sounds good. How can you look at the periodic table and make sure that the end of that is correct? It's where it's located. So I'm in the 2nd row, I'm in the P block, and I'm in the 3rd column over. And that's where you'd find the nitrogen. Okay. What about the phosphorus? Three P3. Same situation with this, right? I go to the 3rd row, go over to the P block, and in the 3rd column, I've got myself a phosphorus. All right, what about the selenium? One S2, 2S2, 2P6, 3S2, 3P6, 4S2, 3D10. Oops. 4P3. What do these 3 elements have in common? They're all in the P3. They're all in the same column on the periodic table, right? What do you think about the reactivity of nitrogen, phosphorus, and selenium? Oh, did I have selenium 1 over? Oh, damn it. No, sorry. Why didn't somebody stop me when I said 3? We're slow. That's your answer. We're slow. 3p4. So it should be in the 4th column. Dang, I meant to put arsenic down there. Okay. Energy level diagram for zinc. So when I'm drawing the energy level diagrams, I got the energy here is my y-axis. So as I go further up, I have a greater amount of energy to deal with. And so with zinc, how many electrons am I dealing with? 30? So how do I start filling that? So there's 1 orbital, 1 orbital, 1 orbital, and 1 orbital for all the S's. I'm just offsetting this just so I can make it obvious. You don't need to. So the P's get 3, and what about the D? Okay. So I've got 2 here and 2 here, and then I've got another 6 here, and I have 2 here, and then I have my next 6 here, and then I have these 2, and then I've got my next, or my final, sorry, 10 here, and there's zinc. Okay. Hund's rule, which one's that?
Each orbital has a small.
Okay, I'm waiting.
Each orbital in a sublevel is singly occupied with 1 electron until all of them are filled with 1. And then the next one will have 2.
I don't think that's going to fit in that area.
Each orbital has to have 1 before any can have 2.
So before you pair them up, you need to make sure that each of the orbitals in that sublevel has an electron. The important part is in that sublevel. It's not like you just throw electrons in each of the orbitals. 1 electron. The only reason I'm allowed to do that, what does it have to do with? Have we ever talked about magnets? No.
Oh, the speed, the energy that it takes.
The energy. So I put 1 electron in each of these p orbitals before I put any, before I double them up, because each of these orbitals here has exactly the what? They have exactly the same amount of energy, so it's totally fine to do that. It doesn't matter which one of those 3 I put it in. Each of those electrons that get put in there has the same exact amount of energy, so it doesn't matter which one I put it in. So I might as well put it in one that doesn't already have something that's trying to push it away. The Pauli exclusion principle? Electrons paired in the same orbital must have opposite spin. Questions? Okay.